now it's ready to move on to the understand the optical transition is possible or not by judging from the integral. And probably those who know this well, you could already predict what I'm going to teach you. And here's the thing. So when the photo absorption by, let's think about depolarized light is induced, the integral is S equal F1 H prime F2 taking the integral in space. And to have a value of this integral, you need to have the I, the F1, F2, F3 multiplied, and these three, the product of these three has to have A1 symmetry, right? So this is a necessary condition. So let's think about this. For example, molecule in C2V symmetry, there's the d orbital, d squared, and then d of xy. Is it possible transition by X-polarized light? That's a question. And we can understand the index values for C2V molecules from this chart. So the dxy is in a category of A2, 1, 1, minus 1, minus 1. And x is here. So B1, 1, minus 1, 1, minus 1. And dz squared is here, A1 symmetry, 1, 1, 1, 1, right? So by using this index value, so dxy, which is A2, is 1, 1, minus 1, minus 1. And the x is B1, which is 1, minus 1, 1, minus 1. And dz squared is A1, 1, 1, 1, 1. So by multiplying 3 instead of 2, and 1, minus 1, minus 1, and 1. Which is actually categorized into B2 group. So not A2, no A1. So meaning that this is impossible transition in terms of symmetry. Right. So you can try this by using, for example, Z polarized light or Y polarized light, and if this transition is possible or not. Okay, so it's given in the exercise, after lecture exercise. So please try it for yourself. Okay. So finally, let's take an example for H2O water. The transition from A1 orbital to B1 orbital is possible or not. So now what you can think about many different the transition you can think of. So we have options of the X-polarized, Y-polarized, and then the depolarized, right? And in water case, water has is included in the category of C2V, meaning the molecular orbitals are categorized into A1, A2, B1, B2, right? So let's check up the A1 to B1 orbital. So what you have to is A1 and then B1 orbital, right? And then B1 is A1 is 1, 1, 1, 1. B1 is 1, minus 1, 1, minus 1, right? And X or Y or Z, you have to think about. But what you have to obtain is, we want to obtain 1, 1, 1, 1, which is A1 category. To make this happen, what we have to obtain is the 1, minus 1, 1, minus 1, right? Obviously. So this must be what's wrong? 1 minus yes, B1, right? So B1 corresponds to X polarized light. So in this case, this must be X polarized light. So you could understand how could optimize the experimental condition for necessary absorption, right? So like this, based on the group theory, which is already included in the many software, and what you have to do is right now is you have to draw the molecules, and the computer can judge if based on the symmetry, also a quantum calculation, and you can obtain the information. However, please keep in mind that there's some rules for molecular orbitals, and there are some criteria to understand that the transition is possible or not, or overlap of molecular orbitals are possible or not. So based on the group theory. Okay, so with that, we finish the group theory of the study of the group theory, and then move on to the optical absorption and the reaction processes of photochemistry.